Physics says your past is still happening, the block time lie. Your past is still happening. You didn't leave it, you're stretched across it. Every moment you've lived isn't gone, it's a slice you'll never stop occupying. You feel a flow because your brain reads slices in order. Physics says the order isn't universal. Get this, there are experiments and equations that make free will feel like theater. But wait, there's a loophole nobody told you about, and it hides where we least expect it. We'll decode block time, the trap inside relativity, the human cost of eternalism, and the cracks that hint at escape. To see why time became a landscape, we need to go back to when speed broke time. When speed broke time, relativity's bomb. Einstein started with a stubborn rule. The laws of physics should look the same to anyone moving at constant speed, and light's speed doesn't budge. That single insistence forced a trade. If light won't change speed, then space and time have to do the bending. Clocks stretch, rulers shrink, and the word now becomes slippery. Here's where it first snaps. Two lightning bolts hit opposite ends of a long train track. A person standing on the platform dead center sees both flashes arrive together and swears they were simultaneous. Meanwhile, someone riding in the middle of the train is moving toward one flash and away from the other. They see the forward flash first, the rear one later. Both are right, because light takes time to travel and the motion changes which light reaches whom when. At the same time, turns into a viewpoint, not a fact. Stakes: if simultaneity isn't real, the present we share is a polite agreement. Presentism wobbles. The smooth, universal now that stories depend on prayers whispered together, countdown clocks, the last look across a room, becomes a patchwork of personal nows stitched by motion. Einstein gave us the equations. Hermann Minkowski gave us the picture. He said time and space are one unified geometry, spacetime. Events are points. Lives are world lines, threads running through the four-dimensional fabric. A person isn't a bead marching along. They're a stretched tube, a world tube with every birthday a coordinate, every goodbye a cross-section. Once you adopt that geometry, grammar changes. Physics stops asking what happens and asks what is. Instead of a film playing frame by frame, you get the entire reel laid on a table. The frames exist, even the ones you haven't watched, yet by moving your eyes along the strip. Meanwhile, something else was happening in laboratories. Time dilation moved from thought experiments to particle beams in airplanes. Muons born high in the atmosphere live longer when racing toward Earth. Atomic clocks flown on jets return a sliver younger than their siblings on the ground. Haefel, Keating, 1971. GPS satellites constantly correct their ticking because motion and gravity skew time. None of this is optional. If you want your phone to know where you are, you have to believe that time runs differently up there. What nobody knew at first was how devastating this would be for the idea of a single, moving present. The relativity of simultaneity isn't a footnote, it's the dismantling of the universal stage. Slice spacetime into nows along one angle and you catch one set of events. Tilt your motion, and your slice catches a different set. There's no privileged way to cut the loaf. Every observer takes their own knife. Here's a human-sized version. Two friends text across a city. One starts jogging east, the other strolls west. Their motion is tiny compared to light, but in principle, the jogging shifts which distant events are counted as now. Scale it up to galaxies, and the effect gets unsettling. As you walk down the street, the set of events you delabel happening right now in Andromeda slides from a future battle to a past truce, depending on whether you're stepping toward or away from it. That's the Andromeda paradox. Reetdake Putnam, 1960s, in Everyday Shoes. You didn't cause a war or a peace. You just revealed how now isn't a shared slice. But there was one problem for people who wanted to keep a flowing present: acceleration. Maybe they hoped when someone speeds up or turns around, the world will pick a single timekeeper. The twin paradox crushes that hope without mercy. One twin rockets to a nearby star and returns. She steps off the ship younger. Her path through spacetime had less proper time. Through the journey, her present never aligned with her twins. The reunion is where their slices finally cross. The younger twin isn't a paradox, she's a measurement. Inside this geometry, causality survives. Light cones, the limits set by the speed of light, keep events in order where it matters. If an event can affect you, it lies inside your future light cone. If you can affect it, the reverse holds. That structure is rigid even while now sways. So we lose a global present but keep cause and effect. The language shift is the quiet revolution. When you say the meeting is at 2, relativity asks, according to which clock? In which frame? When you say it happened at the same time, physics replies, for whom? The more precisely you pin down speed and position, the more you reveal that simultaneity isn't a property of the world but a relationship between an observer and events. Impact? The move from flowing time to laid-out spacetime doesn't just redraw diagrams, it changes what it means for something to exist. If all the points are there, yesterday's fear, tomorrow's resolve, then change is the way a worldline threads through scenes, not a global river pulling everything along. To understand why the block became tempting, remember the bargain we made. Keep light speed fixed, let time flex. That flex unglues a universal present. And once you lose that, the cleanest picture is a block where every event sits, waiting at its coordinate, while different observers swivel their slices and argue about now. Minkowski didn't just add a dimension, he erased something you rely on. The block, Minkowski's terrifying upgrade. Henceforth space by itself and time by itself fade away into mere shadows. Minkowski didn't hedge 1908, he welded them. In his picture, you don't live in time flowing, your life is a geometric object sitting inside spacetime. Events aren't beads popping into existence and winking out, they're coordinates in a four-dimensional map. The train, the platform, the lightning, each is a point. Connect points that belong to the same enduring thing and you draw a world line. Thicken the line to cover the physical extent of a body, and you get a world tube. Get this, your body isn't fully here in the present. It's stretched from birth to death as a long, tapering tube. Tuesday at 3:17 is a circular slice through that tube. Wednesday at 9:02 is another. You don't come into being and then go out of being. The tube already includes the infant in the hospital, the teenager at the bus stop, the older you paying a bill in the quiet kitchen. Walk the tube and there you are. That's Eternalism in street clothes. The view says all events exist. The yard of reality doesn't grow, it just is. What we call flow is the order in which a conscious observer samples slices along a time-like path. Presentism, only the present is real, tries to keep a moving spotlight. Minkowski's geometry switches off that lamp. There's no global now to light, just many valid ways to slice. Here's a human moment inside this hard picture. You flip open an old photo, a birthday with a paper crown frosting on your chin. Eternalism says that scene isn't gone. It's a slice of your tube as real as this one, just not the slice your brain is currently consulting. Grief becomes a geometry problem. The person you lost is still located along their tube. You can't reach that coordinate, but the event exists in the structure. That thought can steady your breathing or hollow it out. Hold on, this isn't about minimizing loss. It's about locating it so you can breathe. But there was one problem for those hoping change is something more than indexing. If everything sits in the block, where do choices live? When did the decision happen? In the block view, choices are features of worldlines, branching causal webs etched into geometry. Your reasons, doubts, and sudden clarity are regions of brain activity at particular coordinates. Becoming turns into being different at different slices. The tension spikes when we talk about agency. If the future is as real as the past, does deliberation matter? The compatibilist move lives comfortably in the block. Your decision at Tuesday 3:17 is part of the full shape and it causes Wednesday's outcome. Cause still runs along the arrows embedded in the block, inside light cones, so agency isn't fake. It's how certain tube regions push others. But the metaphysical openness, the sense that several futures are possible from right here, doesn't fit. in this geometry could have means in nearby physically possible blocks, not in this one. Meanwhile, something else was happening to language. Physicists started saying, this event is space-like separated instead of this happened at the same time. They said worldline intersects instead of we met. That's not pedantry, it's a worldview. When you stop asking what time is it, and start asking what's the space-time interval, you've already accepted that time isn't a universal river but a coordinate you rotate with speed and gravity. Walk the block with a map in hand and you see how change hides in the slicing. Take a loaf of bread marbled with olives. Each cross-section looks different, the pattern shifts, olives drift. Did the olives move? In 3 dimensions, they sit fixed. In the 2-dimensional slices, they seem to slide. The block is like that. The movement is the way our slice intersects a fixed arrangement. If that sounds like a trick, remember the payoff. The block explains why relativity's contradictions evaporate. The jogging friend and strolling friend disagree about which distant events lie on their now, because they're cutting the block at different angles. No paradox, just geometry. The twin paradox becomes 2 world lines of different lengths between the same endpoints. No mystery, just different proper times. There's a cost. Meaning, memory, and mourning have to be rebuilt. Memory becomes a physical record, correlation stored in a brain pointing to earlier slices. It's why you recall breakfasts, not suppers you haven't had. The asymmetry isn't because past slices exist more. It's because your tube carries records toward one direction. We'll follow that trail when we hit entropy. Foreshadow the next twist. Quantum mechanics won't soften this picture the way you hope. Some interpretations graft branching onto the block. Others keep collapse but refuse a single frame to host it. Before that storm nailed down the ground, without a global clock, now is a local cut, and existence is the whole sculpture. And yes, Einstein, Minkowski set this stage in the early 1900s. The lab confirmations, muon lifetime, Haefel, Keating atomic clocks, GPS, lock it in. Minkowski didn't offer comfort, he offered clarity. You wanted a river, he gave you a map. Killing the present, simultaneity isn't real. We've got the block on the table. Now pull the thread that unravels the cozy idea of a shared present. There isn't one. Not in any frame-independent way. In special relativity, you can draw infinitely many now slices through the same spacetime, and each is as valid as the next. That's not a technicality, it's a demolition. Start small. You're standing still, I jog past. We both point at a distant supernova and say, is it exploding right now? In my moving frame, the slice that counts as now snags one set of far-off events, in yours a slightly different set. Locally, we agree on what's happening here. Non-locally, our nows split like pages cut at different angles. Ask, so which is the real present? Physics shrugs. There isn't a unique answer. Acceleration doesn't rescue us. People try to smuggle in a privileged clock by saying, but the world feels different when you turn around. It does. Still, the math never singles out a universal present. The twin paradox is your lived reminder. One twin coasts to a nearby star, turns and returns. She experiences less proper time, so she's younger at reunion. Through the entire voyage, there was no global slice that both called now. Only at the crossing, hello on the launch pad, hello on the tarmac, do their slices coincide. The younger twin isn't a paradox. She's proof that proper time is path-dependent and now is parochial. Want a city-sized version? 2 siblings keep a nightly ritual. Text good night at 10:00. One works a late shift and takes the subway north. The other rides a bus south. They tap send together by their phones, but if you extend their frames to distant galaxies, their simultaneous texts align with different cosmic events. The ritual holds locally because phones agree in a shared network convention. The universe did not sign that convention. Meanwhile, something else was happening in our heads. We're wired for a single stage where scenes roll past together. That stage never existed outside small neighborhoods of spacetime. The bigger your theater, the more you're stitching with assumptions. Relativity of simultaneity doesn't say you can't coordinate. It says your coordination is bookkeeping, not a metaphysical spotlight. Here S where the Andromeda paradox bites. Two pedestrians pass on a London street. One leans forward into a brisk walk, the other leans back, slowing. Because their motion is different, the set of events they'd label as now in Andromeda differ by days. From one viewpoint, a distant fleet has launched. From the other, those ships are still fueled on the tarmac. No signal outruns light, no influence jumps. It's simply that now at a distance has no frame-independent meaning. The paradox is a mirror we hold up to our prejudice, that the universe should share our clock. Stakes, they're personal. If there's no single present, then the feeling that we meet inside a universal moment is something we create by syncing signals, not something the world provides. Weddings, vigils, countdowns, these are feats of engineering, not revelations of cosmic time. Comforting, maybe. Humbling, definitely. But cause and effect, you say, doesn't that need a present? No. Causality runs along light cones, not along present slices. If an event can influence you, it sits in your past light cone. If you can influence it, it lies in your future light cone. This ordering is absolute across frames. No matter how you slice, nobody makes effects precede causes inside allowed paths. The present can splinter. Causality holds the structure together. Let's ground it in a micro story. An astronaut, Maria, signs a contract, a 6-year round trip to a nearby star near light speed with hard burns at each end. Her partner, Eli, stays. They agree to send scheduled messages, one per month by ship's clock, one per month by Earth's. Maria's months are shorter in Eli's frame. Eli's months are longer in Maria's. Messages drift, pile, and then thin. Each reads them now, but their nows never match except at launch and landing. When they reunite, Maria has aged 8 years, Eli 12. Their present never synchronized, their love did anyway. Impact? The block gains teeth. If no global present exists, there's nowhere to hang a moving spotlight that sweeps reality into being. The idea that existence arrives, frame by frame collapses. What exists is the four-dimensional pattern. What feels like arrival is your path through it. This was the moment everything changed for those hoping to salvage presentism with special cases. You can keep a present inside your lab, your ship, your street. You can even define conventional time slices for a nearly uniform cosmos. But the physics refuses to elevate any of these to an absolute. The present isn't killed by cynicism. It's killed by geometry. If physics erases now, can quantum randomness bring it back? Quantum trouble, does collapse rescue time? We just saw the present dissolve under relativity, so maybe quantum mechanics can rebuild it. Measurements feel like moments that actually happen. You open the box, the cat is no longer both alive and dead. That sure sounds like a privileged now, the instant uncertainty gives way to fact. Copenhagen-flavored stories lean into this. A system evolves smoothly, wave function spreading across possibilities until a measurement. Then collapse, probabilities become outcomes. It's tempting to say, that's when reality updates. If collapse is a real physical process, maybe it pins events to a universal present and saves the flow our brains insist on. But there's one problem, no preferred frame. In relativistic quantum field theory, the rules that keep light speed sacred don't leave space for a global hand clap that collapses the universe all at once. If two detectors are space-like separated, which one collapsed first? In one frame, A triggers before B. In another, B leads A. Experiments agree on joint correlations, but not on a universal order of happenings. The math is built to be frame agnostic. Any collapse story that singles out a cosmic clock clashes with the symmetries the rest of physics guards. Okay, so punt collapse to an observer's knowledge. Then it isn't a physical slash through the wave function. It's a bookkeeping update when you learn something. That keeps Lorentz symmetry happy, but the now you rescued is just your mental timestamp. Reality didn't blink, you did. What about many worlds? No collapse at all. The wave function never pinches to one result, it branches. Every outcome with non-zero amplitude gets realized in a larger structure. From your seat inside a branch, you experience one definite result and call that what happened now. The block becomes a branching block. a vast supergeometry where each worldline fans into copies at decohering interactions. Does that restore a special present? Not really. It multiplies futures without privileging a slice. The branching has no global timekeeper. It's defined by interactions and decoherence, which are themselves frame-compatible processes. The moment you feel is a local narrative thread, not a cosmic sweep. Try the pilot wave route. Bohmian mechanics adds hidden variables, particle positions shepherded by a guiding wave. Outcomes look definite because particles always had definite trajectories, just unknown to us. You get determinism back, and with it, a clean story about what's real at every coordinate. But there's a catch. To reproduce quantum correlations, the guiding dynamics is non-local. Many relativistic extensions introduce a preferred foliation, a hidden slicing of spacetime, to define how influences connect instantaneously at a deeper level. That can work as a model, but it reintroduces a background structure that relativity never asked for and experiments don't see. You can hide the foliation, make it empirically inert, and keep predictions. If you do, it doesn't give you an observable present. It gives you a theoretical scaffolding you'll never measure. Meanwhile, decoherence explains why the world looks classical without invoking a literal collapse. Systems entangle with environments, and interference between macroscopically different states dies away fast. Records form, pointers stay stable. You, embedded in that environment, only find yourself in branches where those stable records agree. It's persuasive, powerful, and it doesn't pick a global now. Decoherence is local, continuous, and compatible with relativity's patchwork of frames. It explains why you experience a single outcome, not when the universe flips a switch. Maybe we can force collapse to be objective and fast. Models like GRW and CSL propose spontaneous hits, random collapses sprinkled through time that localize wave functions. They make testable predictions, and people are actively trying to bound the collapse rate. Helpful? Yes. A universal present? No. Those hits are stochastic processes defined so they don't break relativity's statistical structure. They happen relative to local dynamics, not to a master clock visible in the sky. If you insist on a hidden absolute time to schedule them, you're stepping outside confirmed symmetries just to soothe a metaphysical itch. So where does now live in quantum physics? In the same place it lived in relativity, on worldlines, in records, in correlations that define who knows what when. The quantum upgrade isn't a rescue, it's a twist of the knife. Either you accept a branching superstructure where all outcomes exist, or you accept hidden variables that may smuggle in unobservable slices, or you accept collapse as an effective rule for updating beliefs. None of these gives a frame-invariant present. Stakes, big ones. If the micro-level refuses to bless a single happening, the human feeling of arrival can't be anchored in fundamental laws. We meet our moments because brains write records in one direction and call the accumulation now. That's not defeat. It's a clue. Here's the clue spelled out. Everywhere quantum theory talks about events, clicks, tracks, spots, it also talks about information. Who holds it, how it spreads, where it's stored. Decoherence and quantum Darwinism, show how redundancy makes facts subjective. The world looks like it flows in the direction information becomes redundant, copied, and robust. That's an arrow, not a spotlight. If microphysics won't restore a universal present, maybe the reason we feel time's pulse sits in something thermodynamic, entropy, records, memory. Let's go there, because if anything can explain why the block feels like a river, it's the one rule that never points backward. The arrow, why we remember the past, not the future. We've got a block, no universal present, and quantum mechanics that won't grant one. So why does time feel like a pull in one direction? Start with the least glamorous hero, entropy. In a closed system, the number of microstates that match a messy macrostate vastly outnumbers those that match a tidy one. Left alone, systems wander toward the states there are more ways to be. That drift, entropy increasing, is the thermodynamic arrow. You don't watch that arrow, you ride it. The coffee cup on your desk can shatter into thousands of configurations the floor can host. There are far fewer microarrangements that assemble back into a warm mug with steam curling just so. So it doesn't. Not because physics forbids it, but because it's unimaginably unlikely. In daily life, unlikely becomes never. That asymmetry isn't about laws being different forward and backward. It's about initial conditions and counting. Records are where this gets personal. A photograph is a low-entropy structure that correlates with an earlier scene. Scratches in bone, ash in soil, grooves on vinyl, these are traces. They persist because they're embedded in patterns that are robust under small disturbances. And they almost always point backward. You have memories of breakfast because your brain wrote stable correlations with that event and carried them forward as entropy rose. You don't have memories of tomorrow's lunch because no stable record of it exists in your current slice. The trick is, physics is mostly time-symmetric at the micro level. Reverse a movie of colliding billiard balls and the equations still hold. So why do records accumulate only in one direction? Enter the past hypothesis. The universe began in a ludicrously special, low-entropy macrostate. The early cosmos was smooth. Matter and radiation spread nearly evenly, tiny ripples aside. From that starting point, there's an enormous phase space of higher entropy futures to wander into. That's the price of an arrow. You have to pay up front with specialness. You might ask, why that beginning? Nobody knows in a way we can test yet. Some proposals try. Inflation smooths the early universe and seeds the structures that later form galaxies. That's helpful, but it doesn't eliminate the need for an initial condition that allowed inflation to start. Others, like ideas from Julian Barber, explore whether arrows can emerge from generic relational configurations. Those are live debates. What's not debated is that our observed universe behaves like it came from a low-entropy past, and that's enough to generate a thermodynamic gradient we feel as flow. Meanwhile, something else is hiding inside entropy: information. Shannon taught us that uncertainty and information are twins. When entropy increases, information about precise microstates becomes less accessible. But macroscopic records are copied redundantly. Photons scatter off your face, bounce into walls, get trapped in sensors. This redundancy is exactly what makes the classical world stable in decoherent stories. Pointer states survive because information about them fans out into the environment. The flow you feel is the direction in which copies proliferate. That direction is the one where entropy climbs. Here's a micro-story you've lived. You drop that coffee mug. It explodes into shards. Your heart jumps. You freeze. Then you take a breath and start picking up pieces. You can't unshatter it, but you can reduce local entropy by doing work, importing order from your muscles and the power grid that charged your phone alarm. You're a little engine surfing a cosmic gradient, constantly offloading entropy to keep a pocket of order going. Life is a coordination trick that leverages an environment heading downhill to maintain structure for a while. Your brain's narrative machine rides that maintenance as it writes and retrieves records, giving you a sense of past moving into future. Does the arrow explain the feeling of now? Not directly. It explains why you have asymmetric access. The past is full of durable traces. The future is. When you predict, you're extrapolating patterns you've recorded. When you remember, you're reactivating stored correlations. The block hasn't changed. Your position within it sits at a coordinate where backward-pointing records are dense and forward-pointing ones are absent. Experience takes that asymmetry and narrates a flow. There's a common worry. If the block is fixed, what makes the arrow real? The answer lives in the arrangement. The block contains a low-entropy region on one side of your world line and higher-entropy regions on the other. The gradient is part of the geometry. Inside the map, creatures like us exist only where that gradient supports memory making and prediction. So the arrow isn't an overlay. It's a structural fact about the distribution of states within the block. We're biased samplers. We show up where arrows can be felt. Zoom out to galaxies. Gas clouds collapse under gravity, radiating away heat, forming stars that fuse, producing free energy flows. Planets collect, atmospheres circulate, chemistry churns. All of this is entropy management, local decreases powered by larger increases. On a kitchen scale, it's the freezer dumping heat into the room. On a cosmic scale, it's starlight pouring into cold space. The arrow is that cascade. Stakes, they cut straight into meaning. If flow is the story a record-writing brain tells while riding an entropy gradient, then nostalgia, regret, and anticipation are modes of interacting with records and gaps. You can't access future slices because nothing in your current state encodes them. That doesn't trivialize your choices. It clarifies them. Acting is about shaping which records will exist in later slices along your tube and others. The arrow is the canvas. Agency is the brush stroke. Impact. The arrow gives block time a heartbeat you can hear. It tells you why you remember the past, not the future, and why hope and dread point forward, not back. Which sets up the next question. Inside a fixed map with an arrow, what does it mean to choose? Free will in a frozen landscape. So we're standing inside the block, feeling the arrow and staring at our own world lines. Here's the hard question. If the map is fixed, what does it mean to choose? Determinism in relativity sounds merciless. Every event is a coordinate. Every twit of a neuron is a point already placed. But get this, cause and effect still run inside light cones. That's where a compatibilist wedge fits. Your deliberation, your weighing of reasons, your sudden insight, those are not illusions floating above physics. They're specific regions of brain dynamics that push downstream coordinates. Agency doesn't vanish, it gets relocated. Think of a surgeon on Tuesday at 3:17 p.m. Her patient's blood pressure is dropping. Seconds matter, her hand trembles. She recalls a paper she read last month, hears a resident's quiet, we can try vasopressin, checks the monitor and decides. In the block, that scene isn't being minted, it's already a slice. But inside the slice, causal arrows run from the surgeon's trained networks to the clamp she places, to the wave that steadies on the screen. The choice exists where it always did, as a pattern that produces consequences. The fact that the map contains the pattern doesn't cancel the doing, it locates it. Here's where people stumble, they equate fixed with futile. If the future is real, they say, nothing I do can matter, flip it. Matters means makes a difference in what follows along reachable paths. The only way a choice wouldn't matter is if downstream coordinates ignored it. They don't. Your reasons are part of the cause web that determines what happens next. Remove them and the block's story is different. Add them and the story is this one. You're not outside physics pushing, you are the push. But there's one problem that needles, the sense of open alternatives. When you stand at the crossroads, it feels like several futures are equally possible. In the block, only one of those branches is realized in this universe. So what are we feeling? Uncertainty about which slice our records will soon reveal, plus counterfactual skill. Brains simulate nearby possibilities. If I turn left, traffic. If I turn right, detour, to guide behavior. That modeling isn't a metaphysical fork. It's a decision engine that shapes action. We experience the simulation as openness. Its function is selection. Bring in the neuroscience that spooks everyone. Libet found readiness potentials, electrical buildup milliseconds before a subject reported the intention to move. Later work complicated the picture, but the headline stuck. The brain decides first, consciousness lags. You could read that as a death sentence for will, or you could read it as timing in a layered control system. Motor circuits prep options, higher level processes gate, veto, and contextualize. In the block, all of that is a single coordinated pattern. The veto, if it happens, is as real as the readiness potential. Agency isn't a spark that appears ex nihilo. It's the architecture that prunes impulses into actions aligned with values. Meanwhile, something else is happening across timescales. What you call you isn't just the instant of choice. It's the whole trained apparatus built over years, habits, memories, language, norms, etched into a nervous system by sleep, practice, and feedback. When you act, that long arc leans on a moment. Determinism here doesn't erase responsibility, it grounds it. Responsibility means this action flowed from the kind of agent you are. change follows the same path. You become a different kind of agent by altering routines and environments that will, at later slices, produce different reflexes and reasons. But if it's already in the block, you ask, can I do otherwise? In one sense, no. This block contains the unique history that includes your choice. In another sense, that matters for living, could have points to policies and capacities. If your reasons had been different, if you knew the clamp was defective, if the resident hadn't spoken, you would have acted differently. That counterfactual truth is about sensitivity of your decision-making to reasons. That's the version of could that our practices of praise, blame, and law actually track. There's a practical payoff. When you adopt a compatibilist stance inside the block, you stop waiting for metaphysical permission and start tuning the system you are. Sleep more and future slice you will deliberate better. Change your context and downstream behavior shifts. Teach, nudge, design incentives, write reminders. These are ways agents restructure the very world lines they inhabit. It isn't pretense. It's physics, altering present inputs to alter future outputs within your light cone. Impact? Free will becomes the felt surface of deep structure. It's not spooky freedom from causation. It's a causal profile worth wanting, reasons responsive, reflective, improvable. That's enough to carry meaning, love, art, and law without lying about geometry. Critics push back. Block time isn't proven, just elegant, fair. So we stress test it. What happens when gravity joins the party and time itself starts to wobble? If the block cracks at the Planck scale, maybe becoming sneaks back in. Let's press on the seams. The cracks. Does quantum gravity break the block? We've leaned on a clean spacetime map. But the moment gravity flexes, the map wrinkles. General relativity already told us there's no global master clock, only local ones ticking along world lines, redshifting in wells, stretching on mountaintops. When we try to quantize that, time itself stops showing up the way we expect. The problem of time isn't a slogan, it's a roadblock with physics stamped on it. Start with the canonical route. You take Einstein's equations, slice spacetime into evolving spatial geometries, and ask for a quantum wave functional over shapes, universes as configurations. The equation you get, the Wheeler-DeWitt equation, looks brutal and simple at once. No explicit time parameter, just a constraint h psi equals 0. The universe's wave function is stationary. Where did evolution go? People call this timelessness, but it's not nihilism. It's a hint. Time might be relational, not absolute. A bookkeeping between subsystems, not a global metronome outside the system. Here's one way out that doesn't require a cosmic clock on the wall. You pick a degree of freedom to serve as a clock, maybe the volume of the universe, maybe a scalar field, and you ask how everything else changes with respect to it. That's internal time. Evolution reappears as correlations. When the clock reads this, the rest looks like that. The story becomes, this happens when that reads 12, not at t equals 12. It's motion without a master parameter, and it fits what relativity already whispered. Only coincidences are physical. Meanwhile, loop quantum gravity attacks from a different angle. Instead of a smooth continuum, it builds geometry from discrete excitations, spin networks, graphs with edges labeled by quanta of area and nodes carrying volumes. Space becomes atoms of geometry. Areas and volumes have smallest non-zero eigenvalues. Time, not an external slider. Changes are local moves in the network, transitions in a spin foam, a history of spin networks morphing into one another. There's no universal tick. You recover familiar spacetime only in coarse-grained limits, when countless microscopic transitions smear into a geometry that looks smooth. Becoming sneaks back as an emergent process, not a spotlight sweeping the block, but a combinatorial growth of relations that, at scale, reads as geometry evolving. Causal set theory takes the discrete hunch and makes causality the backbone. Forget lengths and angles. Start with a partially ordered set of events, a sprinkle of elements where the order encodes who can influence whom. If you recover spacetime, it's because the order is rich enough and faithfully embedded into a manifold. Some versions let the set grow. New elements are born according to probabilistic rules that respect causality. That sounds like an objective becoming. The set expands, the past is fixed, the future not yet grafted. The catch is subtle. The dynamics has to be label invariant, no preferred birth order beyond the causal order. You get growth without a synchronized present. Still, the language shifts. We speak of birth events, not just coordinates. Other programs explore the same hunch from different scaffolds. Asymptotic safety suggests gravity could be well defined at arbitrarily high energies because couplings flow to a non-trivial fixed point. No lattice, no background metric needed a priori. The continuum is a large-scale phase. Causal dynamical triangulations glue together tiny simplices, triangles in 2D, tetrahedra and beyond, to build spacetimes, but with a crucial rule: respect a causal structure. Sum over these discrete geometries, and in simulations, an extended four-dimensional universe emerges. The macroscopic block looks like it's carved out of microscopic combinatorics. Time at the base is a parameter indexing layers of triangulations, not the experienced flow. Yet the need to maintain causal order hints that ordering, at least partial, precedes geometry. Zoom back to the Wheeler, DeWitt frame and another escape route, semi-classical time. Split degrees of freedom into heavy, slow variables. Think the large-scale geometry and light, fast ones matter fields. The heavy sector acts like a background clock. The light sector obeys a Schrödinger-like equation with respect to that emergent parameter. In that approximation, time is back, but it's conditional and approximate. You didn't find a hidden clock. You manufactured one from within, the way a band uses the drummer's foot as reference when the house PA fails. What nobody knew at the outset was how far the time is emergent idea would echo. Quantum information keeps showing up as a guide. If time is correlations, then entanglement could be the stitching that makes sequences meaningful. Page and Wooters proposed a mechanism. Globally stationary states can still contain internal dynamics when subsystems serve as clocks for one another. It's not mainstream cosmology, but it aligns with a pattern we keep seeing. Evolution as conditional statements inside a bigger, constraint-satisfying whole. Stakes, they're sharp. If time is emergent, the block might be a large-scale mirage, a smooth statue carved from grains whose own rules don't mention before and after as absolutes. The metaphysical picture tilts. Instead of a frozen block that's fundamental, you get a deeper level where only relations and orderings exist. Geometry, clocks, and maybe even causality beyond partial orders arise in the limit. That doesn't hand back a flowing present we can all salute, but it opens a door labeled becoming, just not the kind our gut expects. Here's where it gets provocative. If the macroscopic block emerges from rules that update local structures, graphs, sets, simplices, then the flow we feel could correspond to update rules running on a substrate. Not pixels on a screen, but something like them. Finite, local, informational. If that hunch holds, the question shifts from is the block real to what algorithm yields a world that looks like one. If time emerges, the block might be a mirage, but from what? The computation hypothesis, rendering time. We left off with a suspicion. Maybe what looks like a smooth block is the large-scale trace of microscopic updates. That's the computation hypothesis in plain clothes. Not a video game cliché, but a serious question. Can rules that update local information generate a world that, when you zoom out, looks like relativity, quantum fields, and an arrow? Start small. A cellular automaton is a grid with bits that flip by simple rules depending on neighbors. John Conway's Game of Life is the poster child. Trivial code, surprising creatures. Gliders slide, oscillators tick, logic gates can be built. There's no flow written in, just repeated updates. Yet to observers living in the patterns, there's motion, memory, cause. The now is the current configuration. The future is one update away. The past is copies stored in the arrangement of cells. The temptation is obvious. What if physics emerges from something like this, but far richer? Then you run into the first wall. Relativity loathes preferred grids. If updates happen in lockstep on a lattice, you've singled out a universal time and direction. Lorentz invariance, the sacred symmetry of light-speed physics, gets bruised. Can a fundamentally discrete substrate still produce continuous symmetries at large scales? Lattice field theory says maybe. Physicists simulate quantum fields on grids all the time and recover continuum behavior as the lattice spacing shrinks. The key is universality. Different microscopic rules can flow to the same macroscopic fixed point. So a discrete update rule might, with the right design, wash out its preferred frame in the limit. That's a hope, not a guarantee. Meanwhile, something else in quantum gravity carries a computational scent. Holography, ad SCFT, Maldacena 1997, says a gravitational world in the bulk is exactly encoded by a lower dimensional quantum theory on the boundary. Bulk distances map to boundary entanglement patterns Ryu-Takayanagi. Change the entanglement and the geometry shifts. Time shows up oddly here. Boundary time isn't necessarily bulk time. Multiple clocks can coexist. But the striking part is representational. The stuff of spacetime looks like information, correlations arranged in a code. Push that with tensor networks. Build many-body quantum states by wiring little tensors into a web. Run a multi-scale entanglement renormalization ansatz, and you get a layered network that resembles a discrete slice of negatively curved space. Coarse graining up the network mimics moving outward in space. Circuit depth mimics something like time of preparation. You can literally draw a state as a circuit and see geometry as entanglement architecture. The rendering isn't pixels, it's bond dimensions and connectivity. Here's a human-sized analogy that won't overpromise. A game engine stores worlds as data, meshes, textures, state variables. Nothing in the file moves. When the engine steps the simulation, it updates variables according to rules and renders only what's needed for the viewport. The player feels flow because frames refresh, inputs change states, and caches retain history. The world exists as data, but your sense of now is tied to the update loop and the buffers that hold records. Translate that carefully. If the universe is computation, the physical viewport is just another subsystem. What's rendered is what's causally available. What's stored is what's redundantly recorded. The flow you feel tracks update and memory, not a cosmic sweep. But there's one problem you can't hand-wave. Quantum theory is linear and unitary, classical automata are. So you upgrade models. Quantum cellular automata evolve qubits on a lattice by local unitary gates. Quantum circuits do the same, layer by layer. These are discrete time, strictly local, and yet can generate relativistic-like dispersion relations. In some constructions, light cones emerge from finite gate depth. Signals can't outrun circuit layers. The challenge remains to recover exact Lorentz symmetry without a hidden grid, but hints are there. Symmetries can be approximate and tighten with scale. Now fold in quantum error correction. ADAS-CFT behaves like a code. Bulk information is redundantly stored on the boundary, resilient to local erasures. That code-like property gives spacetime its stability. If a small region gets corrupted, the wider pattern still reconstructs the message like a scratched CD that keeps the song. Time, in this view, is the ordering of logical operations. Apply a unitary spread entanglement, write records, repeat. The classical world is what's decohered and redundantly copied, quantum Darwinism by another name. Updates create redundancy. Redundancy creates objectivity. Here S where the arrow sneaks in. In computation, you pay for erasure with heat, Landor's principle. To reset a bit, you dump entropy. If the universe's update rule includes lots of effective erasures, coarse graining, forgetting microdetails, then rising entropy is baked into processing itself. The direction in which information becomes redundant and microinformation disappears is the direction you call time's flow. That doesn't fix initial conditions, but it ties thermodynamics and computation with a concrete bill. Skepticism is healthy. If there's a substrate with discrete updates, where's the experimental scar? Lorentz violating effects have been hunted and hemmed in. We haven't found the grid. So the only respectable versions either hide the discreteness behind exact symmetries or accept it as an emergent bookkeeping. No ontic ticks, just internal correlations acting clock-like. Impact. The computation lens doesn't overthrow the block, it reframes it. The block can be the history of a computation, a fixed record of updates already applied. What feels like flow is our place inside the circuit, a process writing, copying, and pruning information along world lines. And if horizons, gravity, and entanglement are all about codes, then rendering time isn't pixels turning on, it's correlations being woven and stabilized. Get this is the reality loophole without cartoonish simulation talk. Computation as physics, not a gamer in the sky. Whether computed or continuous, one arena stresses any story about time to the breaking point. Black holes. Horizons force us to choose what update, record, and now can even mean when two observers disagree and both insist they're right. Event horizons and delayed doom. You fall feet first, comet first because the numbers on your wrist say everything's fine. The black hole is a dark coin stamped into Starfield, and your ship's clock purrs along while the tidal pull climbs from tug to rip. From your seat, time is ordinary. Seconds stack, heartbeats count, your suit telemetry scrolls. Unknown to you across light towers, your friend watching through a telescope sees a different story. You slow, you dim, you smear into red, and then you freeze on the brink. Two lives, one plunge, and both insist they're telling the truth. Let's ride your world line. Crossing the event horizon doesn't announce itself with fireworks. At stellar mass scales, you feel stretching, spaghettification before the horizon itself, but imagine a supermassive hole where tides are gentle. You glide through a surface that no light can climb out of. Your proper time ticks on. The horizon isn't a wall, it's a one-way gate. Signals from your suit still ping outward, but each ping climbs against a deeper gravitational well, losing energy, arriving later. You don't notice the delay stacking, the outside does. Meanwhile, something else is happening on the distant hill where your friend waits. Photons from your suit take longer routes through warp spacetime. Each carries less energy than the last. The clock on your sleeve, once crisp digits, slows in their image like it's wading through amber. They never see you cross. They collect an infinite series of ever fainter frames that pile up near the edge. A film that asymptotically approaches the final cut but never plays it. That's gravitational time dilation turned inside out by perspective. Neither story is fake. They're stitched to different sides of the horizon. This is where block time bears its teeth. In the four-dimensional map, your world line falls through the horizon and ends at the singular core. Your friend's world line never intersects a frame where your crossing appears. Their light cone can't catch it in finite time. Both experiences live in the block as valid, contradictory-seeming slices that don't actually conflict. The horizon isn't just a border in space, it's a fracture in now. There's a deeper fight staged on that edge, information. Classically, anything that falls in is gone, but quantum mechanics cherishes unitarity, evolution that keeps information intact. Hawking showed black holes radiate. Quantum fields near the horizon produce pairs. One escapes as Hawking radiation, the other falls in. Left alone, the whole shrinks and evaporates over absurd timescales for giants, shorter for tiny ones. Early on, the radiation looks thermal, featureless heat. If the story ended that way, information would vanish. That's the paradox. Enter the page time after dawn page. If evaporation preserves information, entanglement between the whole and its radiation must rise at first. More and more of the whole's quantum secrets get shared with the outside. Then, around the halfway mark of evaporation, the entanglement peaks and starts falling. The late radiation carries out the rest. That's the page curve, a bet that the universe keeps its books balanced. You can't see the bookkeeping in a backyard scope, but the block must encode a consistent story. What falls in is somehow smeared, scrambled, and released. /replacement text /diff edit. Diff edit search text. Now the firewall controversy lights a match. If late radiation needs to be entangled with early radiation to restore information, and near-horizon physics insists a smooth vacuum with entanglement across the horizon, quantum monogamy snarls. One qubit can't be maximally entangled with two partners at once. One fix is brutal: torch the smoothness. Replace the horizon with a firewall that burns anything crossing, breaking the across-horizon entanglement so the far-field books reconcile. But that clashes with the promise of general relativity's placid passage for big holes. Another fix keeps smoothness and pushes the weirdness elsewhere: state dependence, equals wormhole-like connections, or subtle non-locality that ferries correlations without signal abuse. The argument isn't settled. What the horizon demands is a choice about which intuition you'll sacrifice. /search text replacement text now. The firewall controversy lights a match. AMPS 2012. If late radiation needs to be entangled with early radiation to restore information, and near-horizon physics insists a smooth vacuum with entanglement across the horizon, quantum monogamy snarls. One qubit can't be maximally entangled with two partners at once. One proposed fix is brutal: break smoothness with a firewall that burns anything crossing, severing across-horizon entanglement so far-field books reconcile. But that clashes with general relativity's expectation of placid passage for large holes. Other options keep smoothness and move the strangeness elsewhere: state dependence, equals wormhole-like connections, or subtle non-locality that ferries correlations without signal abuse. The argument isn't settled. What the horizon demands is a choice about which intuition you'll sacrifice. Now the firewall controversy lights a match. If late radiation needs to be entangled with early radiation to restore information, and near-horizon physics insists a smooth vacuum with entanglement across the horizon, quantum monogamy snarls. One qubit can't be maximally entangled with two partners at once. One fix is brutal: torch the smoothness. Replace the horizon with a firewall that burns anything crossing, breaking the across-horizon entanglement so the far-field books reconcile. But that clashes with the promise of general relativity's placid passage for big holes. Another fix keeps smoothness and pushes the weirdness elsewhere: state dependence, equals wormhole-like connections, or subtle non-locality that ferries correlations without signal abuse. The argument isn't settled. What the horizon demands is a choice about which intuition you'll sacrifice. Human stakes sneak through the equations. From your perspective, you had a last moment inside the hole, a final memory, a final fear, a final calm. From your friend's perspective, that last moment never arrives. Your image thins and redshifts into background noise. Both are real in the block, neither cancels the other. Grief and physics share a sentence: two observers disagree about your end and both are right for them. Here's the twist that haunts the hilltop watcher. If evaporation encodes information on the horizon and leaks it into radiation, then in principle, hideously in practice, the pattern of photons that arrive over eons contains scrambled facts about your suit, your heartbeat, your jokes on the way down. The horizon becomes a ledger. The universe refuses to forget. That ledger doesn't mean you survived. It means the blocks outside regions carry a shadow of what crossed. Impact? Horizons fracture our shared now and force us to think in world lines and light cones. They turn flow into perspective and make information the currency that never quite burns. At the edge of a black hole, time picks sides, and both are right. Cosmic time isn't your time. While your friend's telescope cools, pan the lens to the biggest clock we have, the cosmos. Cosmology gives us something that looks like a master time, but it isn't yours. In the standard FLRW picture, you average over galaxies, smooth out lumps, and define comoving observers. Imaginary folks riding the Hubble flow, not drifting relative to the expanding fabric. Their synchronized wristwatches define cosmic time. It's clean, useful, and completely indifferent to your jog down the street. Here's the catch. Cosmic time is a statistical convenience. It relies on homogeneity and isotropy at large scales. The universe looks the same in every direction and place when you zoom out far enough. That's mostly true beyond a few 100 million light years. Below that, gravity bunches matter into filaments, clusters, and voids. Your personal now rides a peculiar velocity inside one of those knots. You can adopt the cosmic clock for calculations, but it's not an absolute referee for simultaneity. It's the best average, not a verdict from the sky. Inflation deepens the split between felt time and cosmic bookkeeping. Wind the film back. A tiny patch of space inflates, exponential expansion, iron out wrinkles, erase local memories, and spray quantum jitters across the stretched fabric. Those fluctuations, minuscule differences in density, seed galaxies. Inflation doesn't restore a universal present. It manufactures a consistent arrow by resetting conditions and laundering initial mess. Many versions even predict eternal inflation. While our patch reheats and evolves, other regions keep inflating, spawning bubbles that never share a common now. Cosmic time slices can be drawn inside each bubble, but across the multiverse they refuse to line up. Meanwhile, future infinity starts to look like a black hole turned inside out. A universe dominated by dark energy approaches de Sitter space. There, every observer carries a personal event horizon. Beyond a certain distance, regions recede faster than light relative to you. Signals can't reach you. That horizon has a temperature, a tiny thermal hum, and an entropy proportional to its area. It acts like the black hole's cousin, limiting what can be present for you. Two observers a few tens of billions of light years apart don't just disagree about simultaneity. They inhabit different observable universes with different accessible ledgers. The idea of a single communal future dissolves into a quilt. The long view is colder still. Follow the expansion and star formation falls off. Gas runs down. Black holes dominate, then evaporate through Hawking radiation over fantastically long times. The heat-death picture has the universe drift toward maximum entropy. No free energy gradients, no structure that can record and compute. In a block view, those pages already sit at their coordinates. In our felt time, it's the horizon of meaning, the point at which arrows fade because there's nothing left to write records. Some speculative models dodge the quiet end. Cyclic cosmologies propose bounces. Conformal ideas try to glue the cold future of one eon to the hot birth of the next by rescaling what counts as size. Even then, the clock that runs between eons is not your wristwatch. It's a geometric mapping that trades units to keep equations smooth. Bring it home. The universe offers many clocks, proper time along a worldline, coordinate times tied to choices of slicing, cosmic time from averaging, conformal time that rescales distances to straighten light's paths. They're tools. None of them reboots a privileged present that stretches from your living room to the Virgo cluster. Your neighborhood, now, is just a local cut that plays nicely with the structures around you. Here's a small story that feels big. A team in Chile watches a supernova whose light left when dinosaurs walked. Their tonight captures photons that started before there were humans. At that same tonight, astronomers in Hawaii catch a gamma ray burst from a galaxy farther still. Events that, in any shared present sense, never coexisted. The word tonight is a coordination hack. It binds a human schedule to a jagged, light-delayed reality and lets us act together anyway. Stakes, they're not abstract. If you try to live as if your present is the universe, you'll misunderstand what can be known, predicted, or shared. If you accept the patchwork, you gain humility and precision. Weddings and vigils still matter, but you stop mistaking signal sync for cosmic favor. Cosmic time isn't your time. It's a scaffold we built to navigate an expanding map where horizons move, arrows emerge, and now is always local. The illusion of flow, philosophers versus physicists. We've been living with a physicist's map. Light cones, world lines, entropies push. Philosophers have been arguing about the feel of time for millennia, and they don't give up the stage easily. They split into two camps with labels that sound like train lines, A theory and B theory. A theory says time really flows. There's a privileged present sweeping forward. B-theory says all events simply are past, present, future arranged tenselessly, and flow is how creatures like us experience the order. John McTaggart tried to sink the A-theory with a paradox. He said the A-series, events being future, then present, then past, forces contradictions. If an event is present, it can't also be past, yet any event must be all three at different times. To fix it, you need another time about time, and then another, an infinite regress. He concluded time is unreal. Most people think that's too strong, but the knife cut deep. Claiming an objective moving present smuggles in structure the world doesn't seem to carry. Presentists push back, only the present exists. The past is gone, the future isn't real. That matches how grief hits, how hope works, how regret bites. But special relativity keeps showing up like a stern librarian. No universal simultaneity, no shared slice, so which present exactly is real. Some presentists try to rescue it with a hidden foliation, a cosmic slicing we can't detect. Others try to restrict existence, talk to local here, now, and let distant existence be indeterminate. Both moves pay a price. Either you undermine relativity's symmetry, or you hollow out the claim until it's more attitude than ontology. The growing block offers a compromise. The past and present exist, the future doesn't yet. Reality accumulates. That honors memories and records while keeping openness alive. Then relativity asks again, if different observers disagree on which distant events are present, does the block grow differently for each? If not, which foliation sets the growth? If yes, you've broken the single world you were trying to save. The pressure never lets up. The moving spotlight is more cinematic. The whole four-dimensional block exists, but a privileged spotlight of now illuminates a sweeping slice. It preserves eternalism's geometry and grants a real flowing present. It also lacks a handle. No experiment has ever found the lamp. It conflicts with relativity unless the spotlight tracks a hidden absolute frame. Philosophers can accept that as a metaphysical add-on. Physicists call it unnecessary baggage. So why does the A-theory survive? Because human life leans on it. When someone you love dies, saying they're as real as ever, just at earlier coordinates, can feel like a trick. We count on becoming, on births and ends, to anchor meaning. We plan, we promise, we wait. The B-theory's calm map can read like a diagnosis stripped of bedside manner. But the B-theory isn't heartless. It just grounds the feeling differently. Flow becomes an emergent feature, brains writing, storing, and reading records under an entropy gradient. Change is variation across slices. The reality of a concert's crescendo is the pattern of air, instruments, and listeners arranged along world lines, not a cosmic river pushing notes along. You don't lose the music, you relocate it. Get this, philosophy has its own compatibilist move about time. You can say, the experience of passage is veridical about its content. There are ordered events, asymmetric access, and ongoing processes, and illusory only about a further claim, that there's a global, absolute becoming. The pain of waiting is real. The structure that feels like waiting to the universe isn't a spotlight but a record-accumulating path. Calling that an illusion can be unhelpful. It's more like a perspective artifact that still carries truth about agency and value in context. Meanwhile, philosophers ask physicists for humility. The block picture is inferred from current best theories. Those theories have domains. General relativity bows to quantum gravity at the Planck scale. Quantum mechanics bows to decoherence and measurement when we build devices. If time is emergent there, maybe talk of a fundamental block is like talking about solid tables before atomic theory. Useful, not ultimate. Physicists answer with a challenge. Proposals that restore becoming need cash value. If there's a privileged present, show us the imprint. If growth is real, point to a law that builds the block and respects known symmetries. Without that, we're swapping a crisp, predictive map for vibes that comfort. The human angle won't leave. A widow keeps her partner's sweater because the present hurts and the past soothes. Eternalism says the wedding, the laughter, the last hospice night all exist in the map, untouchable but not annihilated. Presentism says those moments are gone, which honors the rupture but offers no geometry to hold onto. Each picture demands a cost. Either accept reality you can't re-enter, or accept absence you can't soften. Impact? Physics tilts toward B-theory. Philosophy keeps our feet on the ground where living happens. The truce looks like this. Treat flow as a real psychological and thermodynamic phenomenon riding a static geometry that our best equations describe. If you want more growth, spotlights, earn it with a theory that fits the lab and the sky. Okay, so what about you? How do you live inside a block? Living in the block, memory, identity, and meaning. So how do you live when the world is a map and you're the path through it? Start with identity. In the block, you isn't a flicker passing through time. You're a four-dimensional shape, your world tube stitched by chemistry, habits, and relations. The baby in the hospital, the teenager at the bus stop, the older you paying a bill in the quiet kitchen, they're cross-sections of one extended object. Continuity isn't a river's current, it's geometric coherence. Cells change, beliefs pivot, scars appear, but the tube holds the history that makes those differences belong together. That makes memory less like a flashlight and more like an index. Your brain doesn't reach backward and re-experience past slices. It stores correlations, compressed summaries, written by synapses that changed when the earlier slice happened. Later, those patterns reactivate and point to an earlier coordinate. You call that remembering. Forward pointers aren't there. No structure today encodes tomorrow's voicemail in detail, so you can't recall it. The arrow runs through your indexing system. Here S where the voicemail twist lands. The message you'll leave tomorrow already sits on some later slice of your tube. Your friend S tomorrow slice contains it as a recording. You just haven't reached that part of your geometry from within. When you do, you'll feel like you created it. In the map, it's another region where your reasons and motor control align to produce sound waves and circuit states. This isn't fatalism, it's location. You still do the leaving. You just don't conjure it from nowhere when you arrive. Mortality shifts shape too. Eternalism doesn't give you immortality, it gives you location. The person you love hasn't been erased. Their earlier slices inhabit the block as firmly as your current one. You can't visit those coordinates, but you can acknowledge they're there. Some people breathe easier with that thought. The wedding toast exists, the cardigan on the chair exists, the last hand squeeze exists. Others find it colder. Existence without access can feel like absence with extra steps. Both reactions make sense. Comfort isn't mandated by geometry. Agency becomes practice. In the block, your choices are part of the structure. That means act as if isn't pretending, it's participating. When you sleep, you're altering metabolic and cognitive states that will affect later slices. When you schedule a run, you're nudging the tube toward a branch where stamina and mood differ. When you reach out to a friend, you're building records in their tube and yours that carry forward. You don't need a metaphysical open future to justify effort. You need sensitivity to reasons and a gradient that lets records accumulate. We have both. Responsibility, then, is about fit between who you are and what you do. We praise when actions flow from policies we want more of: generosity, honesty, steadiness. We blame when actions flow from policies we want fewer of: cruelty, negligence, deceit. Inside the block, those practices still shape behavior by modifying incentives, training, and norms that sculpt world tubes. A legal sentence isn't cosmic payback. It's an intervention that changes later slices across many tubes, deterring, protecting, reforming. That's not softer, it's aimed. Meaning stops being a prize awarded by a flowing present and becomes a property of patterns. A life gains meaning when its extended shape weaves with others to create stable goods. Care given, knowledge transmitted, beauty made, harm prevented. That meaning doesn't evaporate because the future is already there. It lives in the relations. How your tube threads classrooms, kitchens, sidewalks, ICU rooms, studios. You can measure it in records that persist and in capacities those records cultivate. Now for a micro story that bites. A nurse on a night shift opens a drawer, finds a note you wrote last year. "If you're reading this, I didn't get to say thanks." She smiles, folds it back, and touches the rails of a bed. In the block, the writing, the finding, the smile, and your earlier gratitude are different slices of intersecting tubes. To her, that note lands now. To you, it landed then. The meaning is the weave. The block holds it. The arrow makes it matter to beings who read and respond. Identity's edge gets weirder when memory stutters. Dementia doesn't erase the tube, it scrambles the indexing. The person remains the same extended object. Their current slice can't access many earlier slices. Loved ones bear the indexing for a while. In practice, that matters. Care becomes borrowed memory, and dignity comes from honoring the whole shape, not just the latest slice. The map demands patience. The arrow tests it. There's a daily tactic here. If memories are records and identity is a shape, build records on purpose. Write letters, keep a journal, teach someone what you know. Take photos, but more importantly, annotate them. Train habits you want to rely on when willpower is thin. Leave kindness where future you will trip over it. In a block view, you're not sending gifts to a stranger. You're reinforcing parts of your own geometry. Meaning under eternalism isn't cosmic destiny, it's craftsmanship. You can't change that the map is four-dimensional. You can change what your tube contains, who it touches, what it builds, where it steadies. If that sounds small, it is. Most of what humans value lives in how we stitch our shapes together. The block doesn't flatten that, it archives it. And there's one more twist coming. If spacetime itself might be built from entanglement, if the map is a projection of deeper correlations, then our tubes aren't fundamental lines. They're patterns in a code. Memory, identity, and meaning would be arrangements in that code too, which raises a question we haven't earned the right to answer yet. If entanglement writes the map, what are we really made of? Beyond spacetime, entanglement builds the block. We've been treating spacetime like the canvas. Now flip it. What if the canvas is painted by correlations? Start with a hunch that keeps surviving stress tests. Entanglement isn't just weirdness in quantum mechanics, it's structure. Change the pattern of who's entangled with whom, and at scale, geometry shifts. equals Epper is the slogan that made this vivid. The idea ties two famous initials, Einstein-Rosen bridges, wormholes, and Einstein-Podolsky-Rosen entanglement. The claim isn't that you can fly messages through a lab-made wormhole. It's that the same math that glues spacetime regions together looks a lot like the math that binds quantum systems in entangled pairs. If two black holes are maximally entangled, the bulk description can resemble a wormhole connecting them. No signal beats light. But the possibility that connectivity equals correlation is hard to shake. Push the lens into our best toy universe. Holography, the add-SCFT correspondence. A gravitational world in the bulk, with its distances, areas, and horizons, maps exactly to a quantum field theory on the boundary, without gravity. Ryu and Takuyanagi gave a ruler. The entanglement entropy of a region on the boundary equals the area of a minimal surface hanging into the bulk. Translate. How much a set of degrees of freedom is entangled with its complement tells you how big a geometric slice is. Rearrange the entanglement pattern on the boundary, and the bulk geometry warps. Spacetime becomes a shadow cast by correlations. Tensor networks turn that shadow into a circuit you can sketch. Build a many-body quantum state by wiring small tensors together, nodes with legs that connect to neighbors. The multiscale entanglement renormalization ansatz, MERA, lays out layers. Fine-grained degrees of freedom at the edge, coarse features deeper in. The picture looks like a discrete slice of negatively curved space. Cut a set of legs and you measure entanglement. Count how many cuts you need and you approximate areas. The network doesn't live in space, it instantiates it. Geometry shows up as how hard it is to separate subsystems. Quantum error correction ties stability to meaning. In add-SCFT, bulk operators, things that happen in the interior, can be reconstructed from many different boundary regions, Almeri, Dong Harlow. That redundancy is the hallmark of a code. Lose a few boundary qubits and you can still recover the message. In spacetime language, local bulk physics is surprisingly robust to small boundary disruptions. The block's solidity might be the macroscopic face of a code that protects information from noise. If so, locality itself, nearby things influencing nearby things, isn't fundamental. It's an emergent property of how the code namespaces its data. Here's a microstory computed, not filmed. Two labs share entangled pairs. They're continents apart, yet their measurement outcomes correlate stronger than classical rules allow. Nobody sends a faster-than-light signal, but stitch many such correlations across a gigantic quantum state, and you've built a web where nearness is defined by how entangled pieces are, not by pre-existing coordinates. Pull on that thread and where becomes how encoded. Meanwhile, something else hums beneath: renormalization. To get from microscopic rules to macroscopic laws, you systematically ignore tiny details that average out. In tensor networks, coarse graining literally is the wiring. Each layer is a scale, each contraction is a forgetting. Time can sneak into that process as circuit depth, the order in which you apply unitaries to prepare a state. If you view the universe's state as generated by a circuit, the before and after of operations define a logic of sequence. That logic isn't a universal clock, but it's a scaffold for ordering. What about the arrow? Codes don't just store, they correct. Correction requires syndrome information, redundant bits that flag where errors land. Producing and spreading syndromes looks like the same redundancy explosion we tied to decoherence and thermodynamics. The direction in which correction proceeds, the way syndromes accumulate and get resolved, lines up with the direction in which classical facts harden. If the block is a codes ledger, the arrow is the record of error management written into its margins. Stakes, they're radical. If spacetime emerges from entanglement and error correction, then past and future are arrangements in a code, not rivers that run. Worldlines are stable patterns in that code. Identities are code words with long lifetimes. Memories are redundant encodings that let slices talk to neighbors. And any hope of a privileged present fades further. The code's rules don't broadcast a spotlight. They enforce consistency, correlations that fit together across cuts. Impact. The block could be a projection from a layer where only relationships count. No distances until correlations define them. No time until operations order them. If entanglement writes the map, the pen is the code, the set of rules that weave, protect, and reveal correlations. Which brings us back to your coordinate in this story. Standing at a point on a world tube, feeling a flow that's really a pattern of records being written in a language you were born reading. The flow you feel is your brain story while moving through a map already inscribed by correlations, records, and causes. Responsibility and meaning live in how you shape records along your path, who you help, what you build, what you teach. If you want more of this, how arrows arise from codes, how horizons hide information, and where agency fits, subscribe and join us. Watch next, our deep dive on time's arrow and the simulation loophole. Drop a comment about the moment that changed your view of time, then keep walking. The map's waiting.